Hello, and today we're talking about buffers. Buffers are a system that minimises change in pH when a small amount of acid and base are added. Okay, so how do we make a buffer? Okay, a buffer is made from two things. First of all, you've got to have a weak acid. The weak acid is in this equilibrium here, and most of it will be staying here as HA, only partially dissociated. So what we do is we add some more of the A-, and that can come in the form of a salt. So here, for example, we've got the sodium salt of the phenolate ion. That dissociates in water, and we've got A-. So we have them both present, the HA and the A-, to make a buffer. So how does a buffer work? Generally, a buffer is in this equilibrium, the weak acid equilibrium. We've got HA, we've got A-. Well, if H+ is added from an acid, a small amount, it can react with the A- to make HA. Okay? And the position of equilibrium will shift to the left-hand side, going this way. So that reaction is basically going that way. What's the benefit of that? The H+ that's been put into solution has been taken away, so the pH stays constant, or the change is minimised. If we add alkali, the OH-, you expect the pH to go up, because the OH- takes out the H+ to make H2O. As it does that then, the position of equilibrium moves to the right-hand side and replaces the H+ to minimise the change in pH. Okay, so here we've got an example. This is the carbonic acid and the hydrogen carbonate ion. So that's the A-, that's the conjugate base, that's the weak acid. Okay, and so when H+ is added, the H+ reacts with the hydrogen carbonate ion to make carbonic acid, and therefore the pH change is minimised. And if OH- is added, it removes the H+, and the position of equilibrium shifts to the right to replace it. Okay, so your pH of your blood can be regulated. So, depending on what pH we want the buffer to be, we have to have the right ratio of HA to A-. Okay? So, this all comes back to Ka again and this expression here. So, you've got the A-, in this case the phenolate ion, and HA is ethanoic acid. We want to know what ratio we need of those two to get a certain pH. Okay? So, if we rearrange that, we can put H+ under here. So, the Ka divided by the concentration of H+, that is proportional to that equals the ratio of A- over HA. Okay, so in this case they wanted a pH of 3.2. So 10 to the minus 3.2 will give you the H+ concentration. And here we've got the Ka of ethanoic acid, and so that gives us 0.03. So if you inverse that, you get 35.8. So for every 35.8 ethanoic acids, you have one ethanoate ion, and that will, if you do that, you get a pH of 3.2.